Imagine spending like 4 solid hours just tearing apart nested IAM policies.
Oh, that sounds painful.
Right. You are auditing every role boundary, running the policy simulator a dozen times.
Yeah, we have all been there.
And then you discover your company's production pipeline actually halted because, well, the accounting department got a new corporate credit card and just forgot to update the billing portal.
Oh, man. It is just the ultimate technical gut punch.
It really is. And today we are doing a deep dive into exactly that scenario. It is custom tailored for those of you who manage cloud environments and have, stared down the barrel of a totally incomprehensible failure.
Those are the worst kind of failures, honestly.
Totally.
Yeah.
So we are pulling this from a June 13th, 2026 article by software engineer and technology writer Aaron Rose.
Right, from tech-reader.blog.
Exactly. The piece is titled Amazon S3 Error, AllAccessDisabled, and our goal for this deep dive is pretty straightforward. We want to give you all a structural shortcut.
A very necessary one, yeah.
Yeah, because we want to fundamentally change how you approach this really deceptive 403 error in Amazon S3, basically saving you from the exact rabbit hole I just described.
Because if you look at Aaron Rose's breakdown, an entire engineering team can lose days of productivity over a single HTTP status code.
Just days completely gone.
Gone. All because they misunderstand handles account-level authorization. The cost of misinterpretation here is just massive.
Okay, so let's unpack this a bit. Why is a single error code, a 403, worth an entire deep dive? 403s happen all the time.
They do, and that is exactly the problem. When engineers troubleshoot access issues in AWS, they rely super heavily on muscle memory.
Right, you see an error, your brain just maps it to a familiar pattern.
Exactly. You immediately start executing your standard diagnostic playbook.
Huh.
But what's fascinating here is that the problem Rose highlights is that AllAccessDisabled perfectly mimics the most common routine error in the cloud.
A standard permission denial.
Yes, but the underlying mechanics causing it are entirely different. It requires a complete departure from your standard troubleshooting workflows.
Because if you treat this like a normal permission bug, you aren't just looking in the wrong place.
Right, you were looking at the wrong layer of the entire AWS architecture.
And that mimicry is what makes it so incredibly dangerous, Visually, AllAccessDisabled sits behind a standard HTTP 403 status code.
Which is so deceptive.
It is, because if you are dealing with REST APIs, a 403 generally means, well, the server understood the request but refuses to authorize it.
Yeah, and in the S3 ecosystem, the standard error you see, like 50 times a week, is access denied.
Right, so when your terminal spits out a 403 in a long string starting with A, your brain just auto-completes it to a local IAM failure.
It's just human nature to do that.
Totally. But Rose draws a hard line between these two states. The underlying logic isn't you lack the specific policy to read this object.
No, not at all.
It is the resource itself is entirely disabled. It reminds me of a building. A standard access denied is like, your key not working in the lock of a door.
That's a great way to put it.
Yeah, but all access disabled means the entire building has been condemned and boarded up.
Exactly. You can copy your key 100 times and it just won't matter.
So why does AWS surface this as a generic 403 then? It seems like they could be more specific.
Well, you have to look at the constraints of S3 as a RESTful service. The S3 endpoint processing your API call doesn't necessarily know the complex geopolitical or financial status of your overarching AWS account.
Oh, interesting. It just does this one job.
Right. It just queries the central authorization service. And when that auth service returns a hard global deny, the S3 endpoint just translates that into the most appropriate HTTP code available.
Which is a 403 forbidden.
Exactly. And the psychological trap here is that engineers assume a 403 implies a granular identity-based restriction. They assume the door is locked because their specific IAM role doesn't have the key.
But what AWS is actually communicating with AllAccessDisabled is a full-on structural quarantine.
That's it exactly, a structural quarantine.
If we map that to network architecture, standard access denied is like hitting a firewall rule that blocks your specific IP from hitting a port.
Right, you just need to update the security group.
But AllAccessDisabled operates more like a DNS sinkhole or a revoked SSL certificate at the edge.
That analogy hits the exact mechanical difference perfectly.
Yeah, because it doesn't matter what your local firewall rules say. It doesn't matter what your internal IAM policies allow.
Because the traffic is being black-holed before it even reaches that evaluation logic.
Wow.
Yeah, in the AWS policy evaluation logic, authorization doesn't just look at the JSON attached to your user or role, it evaluates this massive chain.
It's never just the local policy.
Right. It looks at explicit denies, service control policies, or
Wow,
SCPs at
no.
the AWS organizations level, resource-based policies, permission boundaries, session
It's
policies.
a huge list.
It is. And when an account-level block occurs, AWS essentially injects an invisible, unalterable, explicit deny at the absolute top of that hierarchy.
Oh, wow. So nothing else matters below it.
Exactly. Once the evaluation engine hits that global deny, it just stops processing. It never even reads your carefully crafted IAM JSON.
Which explains exactly why diving into IAM is just a complete waste of time for this specific error.
A total waste of time.
But wait, let me play devil's advocate here for a second for the listeners. Let's say I'm an engineer debugging a live outage, maybe prepping for a big meeting.
Okay, picture the stress.
Exactly. A CI/CD deployment to S3 suddenly fails. My instinct is that almost all S3 access issues are permission-related. Someone probably merged a bad Terraform state that messed up a trust policy.
That is the most common scenario, yes.
So why shouldn't I just double-check the IAM policies just in case? Is the signature of AllAccessDisabled really distinct enough that I should definitively bypass checking my IAM boundaries entirely?
Yes. The signature is the key. And Rose is super explicit about this in his writing. Access denied is the symptom of an IAM failure. All access disabled is the symptom of an environmental failure.
Okay, that is a crucial distinction.
It really is. The danger of taking a quick peek at your IAM policies just to be safe is that IAM in a mature environment is just incredibly complex.
Oh, yeah. Thousands of lines of JSON.
Exactly. If you start auditing thousands of lines of code during an active outage, you will inevitably find something that looks suspicious or suboptimal.
Because there's always some technical debt in there.
Right. You might tweak a policy, test it, see it fail, and then tweak another one. And before you know it, you've spent 3 hours introducing actual configuration drift into your environment.
Wow. Compounding the outage.
Compounding the outage, all while ignoring the actual root cause because you were chasing a red herring. Focus solely on IAM, and it sends you in the completely wrong direction.
It is literally the sunk cost fallacy applied to cloud engineering. You spend 45 minutes in the IAM console, you feel obligated to find the solution there.
Yes, exactly that.
So if the standard evaluation chain stops before it even looks at our local permissions, how does AWS surface the actual reason for the condemnation?
Well, if IAM is out, Rose points us straight toward the account level.
Okay.
And the very first diagnostic step he recommends is verifying the AWS account ID itself using something like the getCaller identity command.
So just making sure you're in the right place to begin with.
Yeah, it's the foundational sanity check.
Mhm.
Because in modern architectures, developers don't operate in just a single AWS account.
Right, they're assuming roles across development, staging, production, sandbox environments.
Exactly. Spanning dozens of accounts managed by AWS organizations.
Mm.
If your terminal session is authenticated against an account that has been sandboxed or suspended, but you think you are troubleshooting production,
Then nothing you do will make any sense.
none of it. Once you confirm you are actively querying the correct environment, Rose directs the investigation to 3 specific administrative layers that sit way above identity management.
And those are the AWS Health Dashboard, the billing console, and the root account email, right?
So those 3 exactly.
Hold on, let's look at the billing console for a second. When I first read Rose's article, this blew my mind. Is it really possible AWS is just locking us out because a credit card expired and it's masquerading as a highly technical S3 error?
It happens all the time.
That seems almost like a bug in how AWS handles messaging. Like, why wouldn't AWS return an HTTP 402 payment required status or, I don't know, inject a clear billing error into the CloudTrail logs?
It's a great question. It comes back to the overarching architecture of AWS access control and the security boundary of the APIs themselves.
Okay, how so?
Well, AWS isolates its billing systems from its resource data planes for security and compliance reasons. S3 endpoints are just not designed to natively query financial databases to return verbose financial statuses to an end user running an API call.
That makes sense. You wouldn't want random developers seeing the company's credit card status.
Exactly. So instead, when an account falls into severe arrears, the AWS billing subsystem triggers an automated organizational event.
And that's where that hidden explicit deny comes in.
You got it. It applies that hidden global explicit deny policy we discussed earlier. The goal is to immediately halt all API actions that could provision new infrastructure or transfer data out.
Stopping the bleeding, basically.
Right, stopping the account from accruing further debt. The side effect, though, is that an engineer running an S3 getObject command simply hits that global deny.
And they get the standard AllAccessDisabled 403 error.
Exactly, completely unaware that the accounting department's corporate card expired 3 days ago. If we connect this to the bigger picture, not every S3 error actually originates in Amazon S3. Sometimes administrative or financial issues just manifest as technical roadblocks.
That makes perfect architectural sense, even if it is an absolute nightmare for the on-call engineer trying to fix it at 2 a.m.
Oh, for sure. It's rough.
The technical roadblock is really an intentional failsafe, which leads directly into the next area Rose highlights: the root account email notifications.
Ah, yes, the dreaded root email.
Right. And this is where we get into AWS trust and safety actions. Like, if the bill is paid but the account is still locked, we are often looking at an automated security quarantine.
Precisely. Because AWS runs massive automated heuristics across its entire global infrastructure to detect anomalous behavior.
Like what kind of behavior?
Well, if a developer accidentally commits an active AWS access key to a public GitHub repository, AWS bots often detect that leak within seconds.
Oh, wow. Seconds.
Yeah. Similarly, if an account suddenly spins up high-compute EC2 instances across 5 different global regions, which is a classic signature for a compromised account being used for crypto mining, AWS trust and safety does not wait for you to notice.
They just shut it down.
They unilaterally quarantine the account to protect both their infrastructure and your liability.
And the mechanism they use to execute that quarantine is the exact same global explicit deny that triggers AllAccessDisabled.
Yes, exactly the same.
But the critical failure point for most organizations isn't the AWS quarantine itself, is it? It's how AWS communicates that it happened.
Right. AWS sends the alert detailing the suspension to the root email address associated with the account.
And the root email is notoriously the weakest link in enterprise cloud management.
It really is. In so many organizations, the AWS account was spun up like 5 years ago by a DevOps engineer who has since left the company entirely.
Or it is tied to an alias like osroot at company.com that forwards to some IT distribution list that nobody actively monitors anymore.
Exactly. So the entire environment is locked down, the engineering team is scrambling, and the exact explanation of why the account was suspended is just sitting unread in a forgotten inbox.
That is wild. It perfectly illustrates why technical problems aren't always technical at their core.
Very true.
We have this heavy bias toward assuming complex systems fail for complex engineering reasons, like we expect a misconfigured VPC endpoint or a crazy routing loop.
We overcomplicate the diagnosis.
Right. We don't expect that a trust and safety bot locked the environment and emailed an inbox that hasn't been checked since 2021.
Which happens more than you'd think.
So let's say we check the billing console, and the corporate card is totally fine. We manage to dig up the root email credentials, but the inbox is empty. We look at the AWS Health dashboard, and there are no global S3 outages reported.
Okay, so the administrative dashboards are completely green.
Exactly, completely green. Yet the AllAccessDisabled error persists. How do we systematically isolate the problem at this stage without just giving up and throwing our hands in the air?
Well, this is where Rose outlines a really solid strategy for scoping the blast radius. If the administrative dashboards don't surface an obvious answer, you have to map the exact perimeter of the failure yourself.
So you can't just rely on that one failing API call as your only data point.
No, not at all. You need to systematically query the environment. You ask things like, does the error occur across all S3 buckets in this account?
Yeah.
Or just one specific bucket? Are other native AWS services, like DynamoDB or EC2, returning similar 403 errors?
And we can map that using CloudTrail logs, right?
Yes, exactly. CloudTrail is your best friend here.
Because if we query CloudTrail and see that AllAccessDisabled is suddenly returning for every assumer request, every DynamoDB read, and every S3 list bucket action across the entire environment,
Then you know it is a systemic block.
it is like diagnosing a network failure. You check if the power is out in just one room, the whole house, or the entire neighborhood.
That's a great way to think about it.
Right. If one container can't reach the database, you check the container's security group. But if the entire VPC suddenly drops all external traffic, you don't check individual security groups.
No, you check the transit gateway or the BGP route tables.
You look for the common denominator. If every service across every user is throwing this specific 403, the problem resides at the absolute perimeter of the account.
And mapping that perimeter gives you the empirical evidence you need for the final step.
Which is,
If your blast radius investigation proves that the block is systemic, but your billing and root emails show absolutely no internal flags, you have reached the hard threshold where you must escalate to AWS support.
oh man, for a lot of senior engineers, opening a support ticket feels like an admission of defeat.
It really does, yeah.
There is this ingrained culture in tech that you should just be able to engineer your way out of any problem using the tools provided.
Yeah, but while that tenacity is usually an asset, in this specific scenario, it is a massive liability.
Really?
Yes. Knowing the boundaries of your own visibility is a critical technical skill. Rose points out that certain internal AWS actions simply aren't visible from within the child account's IAM console.
What about complex edge cases involving AWS organizations' SCPs, like ones applied by a central parent account?
Exactly those two. You literally lack the permissions to see the policy that is blocking you. AWS support engineers have the back-end visibility to see the internal suspension state or the organizational inheritance that is causing the global deny.
So if you refuse to engage them, you will just be spinning your wheels against an invisible wall.
Yep. Knowing when to stop trying to fix it yourself and ask for support is crucial.
Because, you cannot SSH into a router you don't own. You just have to call the ISP.
That's the perfect analogy.
This entirely reframes the troubleshooting process, honestly. We have moved from obsessing over a single line of JSON to analyzing the financial state, the security posture, and the structural hierarchy of the entire cloud environment.
Which is exactly what you need to do.
If we distill all of Aaron Rose's insights down to a single guiding principle for you listening, it is his quote: "Sometimes the bucket is fine, the credentials are fine, the account is not."
And that distinction acts as a shortcut to being a better, faster problem solver. When that specific error hits your terminal, you have to actively resist your baseline training.
Avoiding that dreaded information overload.
Right. You stop looking at the micro level of individual user permissions, and you immediately zoom out to the macro level of the environment's health.
It is a fundamental shift in perspective. Instead of asking, what did I do wrong in my configuration? You ask, what is currently happening to the broader environment I am operating in?
Exactly. You bypass the information overload of digging through thousands of lines of IAM JSON code for absolutely no reason.
You jump straight to get caller identity, the billing console, and scoping the blast radius via CloudTrail.
It just demonstrates why critical thinking and an understanding of underlying systems will always outperform rote memorization of troubleshooting steps. A playbook is totally useless if you misdiagnose the underlying architecture of the failure.
And as we wrap up this deep dive, applying that mindset shift feels relevant far beyond just managing AWS environments.
Oh, absolutely.
Think about how often we default to the IAM troubleshooting mindset in our own professional lives. We hit a wall, a project stalls, a team loses momentum, or a personal goal just feels suddenly impossible to execute.
We always blame ourselves first.
Exactly. Our reflex is almost always to look inward. We audit our own local permissions. We assume we just need to hustle harder, implement a new productivity framework, or fix our own workflows.
When really, that might not be the issue at all.
Right. How much time and energy do we lose endlessly trying to optimize our local configurations when the actual problem is that the broader environment we're operating in, the corporate structure, the available resources, or the overarching organizational health is fundamentally disabled?
That's a great point.
It is definitely worth asking yourself the next time you are blaming your own performance for a failure, whether you are simply trying to open a door in a building that has already been condemned.